Hi, I'm Andrew Armstrong and welcome to the Back Office Teardown Lab, and today do I have an interesting treat for you. I do, because we're going to be looking at these things. I know it's going to be hard to see, so I'm going to zoom in for you. Boom! And these are vacuum tubes, and it'll be clear why we're looking at these in a moment. And I'm not going to pretend I understand how these work, by the way, but just as a sort of let's have a little warm up, pretend we know what we're doing. You have something that looks like a tube. You've seen them like that, and they've got all sorts of gubbins inside and lots of legs. But you can see here, it's showing a rectifier tube like a diode. So you've got a cathode and a plate. And as far as I'm aware, electrons will vaporize off the cathode and head towards the plate. I mean, that's basically how it goes. And you can see here there's a heater. So there's a heater circuit on some of these. And in fact, this one, you can see it says grid here, just about. That is kind of like a transistor. So you've got electrons going from the cathode to the plate. He says, pretending he knows. So you've got current flowing this way, but it depends on the grid. So if you change, I'm guessing grid voltage, I'm not entirely sure here, you can stop that flow. So it is really like a transistor. It really is. So you can almost see the grid is almost analogous to the base on a transistor. And then you've got this thing here called a pentode tube, and then there's all sorts of fancy stuff because they build all sorts of valves, or used to at least, for all sorts of functions. And they were the first, say, precursor to the transistor, and that's where we come in with this. So someone on Twitter, or possibly my Discord, mentioned to me, "Oh, Andrew, why don't you build an AM transmitter?" And I thought, yes, okay, I could build an AM transmitter kit. But I thought, where's the fun in that? We want to do something using technologies that we're not aware of. And I thought, let's see what else we could do. And they did this kit online, which is a valve kit, or rather a tube, a vacuum tube, aka valve. And I thought we'll have a go at that. Let's put all the packing beads away. Now, this was quite expensive. This one was more expensive kits. Certainly a departure from the sort of Chinese Far East kits I normally buy. And in fact, it comes with a massive, whopping great manual and loads of data sheets, from what I can tell. It's a broadcast AM transmitter kit. And not only that, it comes with this plug-in daughterboard thing for medium wave. So this is kind of groovy. I mean, this is the real deal here. But look at these instructions. So it's by ITX Max. It's got the full kit list here, which is nice. I'm not going to go through that right now. I'll just assume it's all there. Shows you pictures of what it looks like and the little daughterboard. All the common problems, all the things to do. Gosh, more stuff. How it functions, the resistor colours, if you're a beginner, what to do. Here's actually literally the resistor colours for the resistors you're going to use in the kit. About the capacitors. This is a really good kit. I think even if you're a beginner, you'll love this kit. Something about if the ITX does not oscillate, then try reversing the wires to the E and the F. Okay, will do. And look, they've even got the frequency winding chart, I think, for this little toroidal daughterboard. Look, turns 15, 3 megahertz. 8 megahertz. The coil in red is recommended for 40 meters and 80 meters bands. So this is like proper FM AM stuff. I'm going to have to try to dig out an FM AM radio to even see what's going on with that. So now, those of you at home who do know what all this stuff is, I'm going to zoom in and show you the circuit here. See if we can figure out what we're looking at. And I'm not going to pretend at all I know what's going on. I think this is the daughterboard here for the toroidal antenna. And these are the power supplies. Now you've got HT here and low T. So I think that's a high tension and low tension. We might need, we certainly might need two power supplies here, because as far as I understand it, actually you need quite a lot of voltage to drive these vacuum tubes. And I'm guessing this is the input here, potentially, J1 and J2. These could be phono inputs. Well, there's a J3 here as well. Yeah. Perhaps I might need to actually read up on this when we actually come to fire it up. but it doesn't stop me starting to assemble it. So I'm going to clear the decks, spread everything out, and we'll start the build. Right, so I've laid things out, and I have to say, just even the feel of these components is nice. They do feel high quality, uptown. And I'm going to actually, I've got to the side of me the instructions, so I'm actually following them because you can see here the resistors don't have the values printed on the silk screen, so I'm going to need those as I go along. So we're going to go for R1 and R2, which are 680Rs. 680Rs, so they should be blue, grey, brown, and that's these ones there, blue, grey, brown, R1 and R2. Go right there. And perhaps I should look at the picture. I'm just going to turn over to the picture, make sure we're assembling on the correct side of the board. It appears we are. So R1, R2. You know, just sometimes it's worth checking. You wouldn't want to do it all on the wrong side. I'm very excited by this. This is my very first thing to use a tube for anything, to be honest with you. My dad certainly has some sort of equipment, old radio equipment, hi-fi equipment that uses these, and I've never really touched them. Always been a bit afraid of them, to be honest with you. They've got big power supplies. I don't really know what I'm doing. However, maybe after this I'll be a bit more willing to try. But they're all constructed in a really interesting way. They don't use PCBs as we know it. They're not like this. They use a kind of basically same sort of fiberglass type board, but everything's point to point wide. I just realised I'd soldered that from the top. I do realise I've been doing that recently, and it is, if you do that, it's fine. It is fine. Just make sure it's gone through nicely. You don't have to solder everything from the bottom. If they're nice sort of through plated pinholes, it's going to be absolutely fine. Right, so R3 is a 4M7, which should be a yellow, red, green, and I think that's the nearest we have. That's the only thing with a yellow in it, so that's going to be R3. And you could see earlier as well, I was just resting it on this, which just happens to be a tube. But look at the packaging. It kind of makes you wonder, how old is this? Is it actually old, or is it just made to look old? Because that's what kind of people expect. So we're going to have a look at that box itself in a moment here. And I'll tell you what it is. So here we go. I'll hold it there while I'm snipping. General Electric, country of origin marked on the tube. And it says, tested at factory for your protection, a 1R5. 165 7569. Oh, there's all sorts of numbers on here. More numbers if you're interested. And there it is, hiding in there. So this would have been just the highest technology of the day, wouldn't it? They are gorgeous, I have to say. So it was made in the US of A, and I don't think there's a massive market for vacuum tubes, so it's probably a new old stock item. Okay, R4, a 1M5, something with brown 2 greens. Brown 2 greens. There we go, R4. Where are you? Where are you? R4, right there. Pop that in. Again, I'm just going to continue to do the top soldering technique. I think that's working out for us. Now, I wonder what sort of power supply I'm going to have to get for this sorted out as well. Maybe it's a sort of, if I'm lucky, it'll be something like 40 volts on the high tension and 5 volts on the low, but something tells me it won't be. I could have a quick flick through the instructions, but we'll do it. High tension is 36 volts, so that's pretty good. I think my bench power supply, let's have a look, what does that go up to? 32, so I think we're close enough. Next resistor, R5. Is that right? Yes, I think we're at the R5 stage. And R5 should be a 4M7, which should be a yellow, red. Ooh, a yellow, red and green. I don't think I've got one of those. We used one of those up there. Look, a yellow, red, well, a yellow, purple and green, but close enough. Don't do this to me. After extolling the virtues of this kit, I find it short a resistor. Curse you. Right, we'll keep going though. R6 is a 2M2, which is definitely this guy, which is a red-green R6. Now really, I don't know where the heck I'm going to get one of those resistors from. Dagnammit. Hopefully it's hiding. Sometimes these components do end up hiding on you, and you'll find it among the detritus on the desk, but I don't know. I think I was pretty cautious today. And I'm just going to put this 100k in while I write it into R7 because it's right next to it on the board. And I still didn't find Power Crazy's resistor leg bending tool. I've really mislaid that now. I'm disgusted at myself for mislaying it because it's such a useful tool. I'm going to have to force myself to get my own 3D printers up and running and just print off one. There we go, got those in nicely. We're going to go the full bolt and braces and do the front and the back as per usual. So I was talking to someone about AM and how do I test AM radio, they said. And they said, well, just use your car. And I was like, well, do cars still have it? And they said, well, yeah, to be honest, most cars just still have that in there. I have to admit, I haven't used it forever. We're talking decades and decades. I don't think I've ever used it, to be honest with you, but I do notice it. You know, it's that mode where you sort of flick over and it's got that annoying noise. Drives you nuts. That's the AM. There's another tube in there, but this is a more anonymous one. Comes in a bit of insulation. So I'm really basically searching for that resistor, but I don't know. I'm going to have to look on the floor later in case I flicked one off. But let's continue anyway. So we've got some capacitors. We've got a 104, 104, and 104. These are Mylar capacitors. So that's C1, C2, and C4 on this board. So there's C4. And we're just looking for the footprint, to be honest with you. C1. Gorgeous. This is gorgeous. It feels really good quality. C1, C2 and C4. That's what I said, didn't I? Yeah, that's what you said, Andrew. That's what you said. Pop them in. Oh, I'm going to turn this one round though. I want all the labels looking the right way. And you're going to say, but you should have done the same with the resistors then, shouldn't you? With all the tolerance bands to one side. You got me there. I'm just going to go with most people's eyes. Won't come across the won't be able to sort of focus on the whatever the resistor's doing if they really care, but they might just read the label off a ceramic capacitor. Right, let's poke these through. So I'm just putting some pressure from the back, flattening up so they're sitting on the bed nice and flat. Yeah, so doing it. So the other day I made another kit, and I might have posted the video on that one. It was on the laser harp, and I was struggling with that, where I actually got a blob of solder in one of the holes, and it took me a lot of fiddling around just to clean that out. And I sort of realised as I was doing it how much time I had spent doing that, and it sort of shows you when you're doing stuff like surface mount repairs, they're so quick in comparison to through hole. And I kind of think that it's an interesting thing because we went to sort of modern technology which isn't quite as repairable, as we all know. They don't even intend for you to repair it, which is sort of surface mount. However, it's the thing that lends itself best to being repaired. from a time, a material standpoint. So funny that, isn't it? Funny old world we live in. So we've got C3 that we skipped, which is a ceramic disc capacitor of 100 picofarads. So I'm going to have a look here. So this is the electrolytic. We know we've got electrolytic, which is C8. Put that aside, but let's see these ones. We've got 3, and they're quite hard to read the writing off them. So this is a 471. Okay. So this could be 471 picofarads. This is a 101. And this one is a 221. So I'm struggling here. Looking at the values, 471 will be 471 picofarads, 221 will be 220 picofarads, and 101 will be the 100 picofarads. So this will be C3 right here. If I can find it. C5, C3. C3 right there. So that's C3. And then we decided that the 471 is C5. Which I'm going to now try to locate. C6, C7. Why am I having so much trouble finding C5? Here it is. And then the other one will be C6. That's the last one. So that's those there. Probably with a bit of struggle, you could solder them from the top. Well, there we go. Let's have a little go, shall we? Let's have a little go. Just because if that does work, and you're building this yourself, you could definitely do that at home. And just save a bit of time or hassle. I'm going to do it just on one leg each, and then I'm going to go around the back anyway. But that just might help the old construction. It's alright for you youngsters with nimble fingers, but you know, us oldies don't have that luxury. That's filled them in brilliantly, actually. That's absolutely great. So just, that's a good tack. Get in there, finish the soldering. Good tack again. They're all great here. That did well, actually. The board's so good. It's a really nice design, high quality materials, very simple there. You can see the thickness of the tracking. It's definitely a really good educational quality board. That's why the instructions, I think, are so good. It's just someone's taken a lot of care. And I'm going to have a look at ITX and see who are they, and you know, why have I not heard of their kits? But it could be all sort of ham radio or radio related, so it's not something we'd have come across, especially if we're used to just buying crappy old kits off eBay. So put the electrolytic in the right way round, of course, and I'm guessing C8 is this one. It has to be the only electrolytic on the board. Pops in right that. And the same thing, I'm going to just tack it because I want to really make sure it's sitting nicely. See, even if it looks like it's sitting nicely, sometimes just you'll feel it. It'll just be a little, 0.5 millimetre, just a little bit of motion. It's good to go. Let's get that off. Right, now we have a switch, on-off switch. It's cute, isn't it? Very cute little 3-way switch. But I haven't got enough hands for this one, so we're going to do the old trick of dispensing my own solder there. Let's see if we can do this. Yeah, that worked okay. You only need to do it on one pin like that because that'll hold it. Then you can do it properly. Get the other ones in. Perfect. So we've got other things to deal with in a minute, which we're not going to focus on, and I'm going to show you those actually, just to let you know. We've got these little daughter boards which are for tuning it, so you'll have to worry about that in a second. Let's see what else. We've got this thing here. That's a big old tuney thing. Is that a variable resistor or a variable capacitor? I think that could be a variable capacitor. It's got that vibe on it. In fact, I'm pretty sure it's a variable capacitor, just from radio kits in the past. I won't pretend I know how they work. It's just what they seem to use. Now I'm just going to push again the back. Make sure it's sitting home. Yeah, it's okay. So I'll be able to now broadcast my phone or iPod or something onto the bands on my car. Give me that retro sound. But in all honesty, actually, I did like the idea of picking up, because sometimes you do see these old radios that are in, looking like they're in sideboards, and they're all like valves and all of that stuff. And it would be neat to be able to sort of have that ye olde sound, wouldn't it? If you could broadcast your modern tunes to these old wireless, you know, the it'd be like the war. It'd be like living in that game. What was that game with the old the whole thing was all underwater? Not Bioshock. I want to say Bioshock, but it might maybe it was Bioshock. Anywho, you know the one. So those obviously are the things that hold the valves in. A bit like spiders. I'm just making sure to get all of the pins in the holes before I crank them in too hard. And they do look like they're about to fall out, so we're going to do a tack solder on those. Let's tack solder them up. Let's go for one in the middle on each. It doesn't look like everything's connected. Let's check that. See those ones that one I've just connected, for example. Yeah, it's just a spare. So I'm going to hold that down. Push it, push. Little push. Again, felt fine. That didn't. Oh no! Alert. Oh, I got to that lovely smell of burning plastic in my nostrils. Should have left me little baggie somewhere else. Right, let's finish these up. So we've got some phonos to put on there. We got some power lead connectors for the HT. But then we're going to have to really, I think the real work is in those toroids. And that's where we can really screw up. So probably ought to take some care over that. And then figure out how the heck am I going to test this, because I certainly can't bring a car radio inside, and I'm kind of sure that I don't have an AM radio in the house, but I could have a little rummage. You never know what you got till you look. They say don't ever seem to go that you don't know what you got till it's gone. I have to say I don't know what I've got anyway half the time. That's looking pretty spot on actually. This is a spanky old kit. I'm definitely a sort of I hear myself going on and on about this kit. Andrew and your bloody kit. Andrew, why do you love that thing? Oh, there's an antenna. One of these is antenna, by the way. That's what that is. I've just seen that in the board. This thing on the left, this one's acting as an aerial. So how the heck am I going to get an aerial? There's a lot of stuff here. And I think when you used to buy radios, and they'd come with a sort of aerial for some of these bands, it was weird. Like one of them was just like a little black stick of ferrite with wire wrapped around it, and some of them was just a bit of wire. So hopefully the instructions will tell me how to make the antenna. But I'm guessing if you're only just going to run it, you know, as tests, we're going to put it next to each other. I think we should just pick something up. I mean, I don't know how keen you are on knowing the full range and all of this sort of stuff. You could probably just ask the manufacturer for that and hope they're honest. Okay, let's do that. Bit of dirt on the old tip there. So what was that thing I've got to find? It was a crazy size, 4 meg. 4 meg, crikey. Where am I going to get a 4 meg from? No Maplins anymore. They have ceased to exist on our high streets. They've gone the way of Tandy. Where am I going to get my spares for my TRS-80 now? The one thing that I always used to marvel at with Tandy or Radio Shack if you're in the US was I'd always pick up one of their catalogues and they always had loads of like Simon style games. Does anybody remember that? Do you remember at home? Leave it in the comment. They had these sort of coloured buttons and they looked like they made loads of noises and sounds. They just looked amazing. I never owned one, to be honest with you, as a kid. But the funny thing is they endured because I remember them as a kid, I remember as a teenager, and I remember them as an adult. So they must have sold loads of those, even though they kind of look cheesy. So throughout the whole Game Boy era and all of that, they would have had those. Those are looking well solid. Those definitely not going nowhere. But yeah, I don't know if anybody... Maybe they're just new old stock again that nobody's ever bought them. Certainly, they're always in the catalogue. I just don't understand it. So this thing here, though, has a whole set of screws here. So I don't know if it's got like some sort of feet. I guess the screws themselves are probably the feet on this. You know, you're going to put the screws in and put the nut and just sit it up. I might be able to find a bit of rubber or something for those to live on. Okay, so that's the things that hold the wires. Again, whoa! Let's see, it came with all of these convenient pieces for helping you. Just consider these ones a tack because I don't trust the alignment of any of that. But maybe I should have. They look really good. There we go. Second guess myself and I guessed wrong. The beauty of this board though is once you're finished doing it, it's really filthy now. There's loads of flux on it. But there's nothing here. Apart from the capacitor. Don't get any board cleaning stuff in that. But everything else you can just scrub. Give it a good old scrubbing. I don't have a problem with that. Now I'm going to fit the feet, and then the only thing left on this particular board is that one resistor. I'm just looking in the bag. So there's a bag which shows you the little boards here. See those things? They've got something in there that looks like resistors, but I'm not sure. I think they might be inductors. So if you've got inductors, those will be measured in Henrys. So that's going to be an interesting one. And also there's a sort of pin header we've got to attach, a pin socket right there. We'll do that one in a moment as well. Okay, got that in. So those are your feet basically, just screws sticking out. But I suspect if you were that way inclined, you could put this inside a fancy schmancy 3D printed box. Okay, got that one there. Right, but before we do that, I think it's worth just nipping those up a touch, because we're never going to want to have to do that again, ever. Are we going to do it properly? I suspect we will. Properly, of course, would be by using a proper socket. I think this will suffice for our needs. If you're really keen, you could get a serrated washer, I suppose, and pop that on there. Are they connected to ground? Yeah, they look like they're all connected to ground, so be careful with that too. If you're mounting it into some sort of chassis, it might be at a different potential. So there's actually an extra screw. I was sort of wondering, do they intend you to put that in there? Don't think so. Doesn't fit right. Right, so I'm just going to take the last thing out of this bag, which is for the daughter boards, without messing with the daughter boards, because I just want that little teeny header. And then I'm going to have to go and have a quick search around for a suitable resistor, of which I think is going to be tricky as heck to find. So this is the only thing that's slightly electronic pitch format now on this whole thing. Everything else is definitely old school, but they've just used a kind of modern style header. Bless them. I do like this whole daughter board idea, though. It's definitely definitely an interesting way to assemble the kit. Yeah. And maybe what I'll do is have a little clean of this board as well before we come back. So let's leave that there, and we'll meet back here with some resistors. As good as gold, as stupid as mud, we'll carry on regardless. Carry on regardless. Carry on regardless. Carry on. Giving it a clean. I've emailed the vendor on eBay to see if they can send me one of those resistors. So I'm not going to fit the valves on this. I'm going to put that aside. And I'm going to work on one of these daughter boards. You have two daughter boards, one which has this toroidal coil, which we have to wire up, but I think I'm going to have to do a bit of reading before that, so we'll probably do a jump cut to that one at some point. But this one looks more fun because this has got some inductors, and inductors can look like resistors, so don't get confused like I did in one of my videos where I mistakenly fitted some resistors where capacitors could go, despite the PCB clearly saying what was what on that one. So we've got LX, LY and CX. So I'm going to have to consult now with the instruction sheet which they are. So you've got three inductors. It's saying you've got two 150s, which will be brown, green and brown. So I'm seeing brown, grey and brown. Could be that. Brown, grey and brown. And then we've got another one which is red, red and black. So that's kind of them. So that's an L1, L2 and L3. That's what they're saying. So we got the board here. And it doesn't quite look like the one in the picture. So both L1 and L2 are fitted the same way round. So at least we know which one's L1 and L2 on this. L3, no mention of L3 so far. And it's saying the gold band nearest the bottom of the printed circuit board. Well, I don't see a gold band, but I see a silver one. So we're going to do that. It's quite specific in how you fit them, because it seems like you adjust the tuning of this by moving these closer or further apart. So they have to sit proud. So let's take a bit of caution. We'll bend these in. And that CX there, that looks like a capacitor. Curiouser and curiouser. Just make you wonder what's the L3 for. Maybe it's a whole tuning thing. Maybe it's part of this other board. It's weird because the board with the toroid, also it's the same PCB. So let's not get confused. So perhaps they're reusing these boards for different purposes. So you've got to have it like that so that you can bend them. So I'm going to leave it like that. It's about 5mm they're looking for, and I think it's probably okay like that. So I'll just leave it sitting up there, and I'm going to come in just behind them with the soldering iron, put a little tack. Here we go. Stop shaking. Good. Gives you the sort of opportunity to adjust them a little bit. I think that'll do. I mean, that's probably a bit more than 5mm. Yeah, it's close enough. I mean, I don't know what the tolerance is. I think the tolerance is enough that lets you adjust them, so they're certainly adjustable. I don't know if that's how you actually tune it, or if once it's adjusted you could just put some hot melt on there and it's done forever. I'll have to figure that one out when we come to it. So the instructions are complicated enough for me where sometimes you're just going to look at the picture, see if it looks about right. Yeah, it looks about right. Just 2 resistors on it. So I don't know what the other inductor's for. Say resistor, inductor. Maybe that's just a tuning one, like you can replace one of these with that and you'll get a different band. Either way, don't bend it. You want to keep that ready for something. So it looks like in the picture it goes on our board like that, like a daughter board. So again, double check, because the daughter board's got an A to F written on it. But this main board doesn't. So different silk screens. It's got 2 sets. I wonder why there's 2 sets of holes on the daughter board. Yeah. So you could use either, and it probably is more stabler on the top set of holes. I think I will leave it on the top set so it's not flopping around. That's fine like that. But somehow, just trying to see if I can solder this in place. Yeah. Annoying about that resistor, eh? For you at home it'll seem instantaneous, but for me I'll have to wait like a few days. It might be the weekend before that comes. I checked the schematic too. That's the resistor that controls the sort of gate on the valve, so it's definitely an important one. Right, I'm going to go study the instructions to the toroid and then we'll check back here and start winding. I have to admit I'm a little bit confused by the instructions here. As far as I can work out, you need to make a certain number of turnings on this, and the amount we're going to go for is 15. That gets us in the low frequency, apparently whatever low frequency is. We have to check the radio is 3 megahertz and the high frequency is 8. So if you do 25 turns though, you'll be the high frequency 5, and if you do only 9 turns you'll be up at the 15. So it's kind of complicated, and it is sided, so you have to be careful of how you end up having to hook up to this. So you've got A, B, E and F are the two things. So I'm going to put it through and I'm going to leave it a little bit proud, I have to admit. See, I'm going to leave them a little bit proud like that and zoom in a bit. You can have a look at me doing this, that's fine. So this is going to be the terminal B, this one that I've got here. So I'm going to bend this back. It's bent, which means it's B. So 1 turn. Good. 2. 3. I might have to start doing it a bit tighter. 3. 4. I kind of want to get it neat. Let's get this a bit neater, shall we? I think you have to have it super tight, but okay, 5. 6. Oops. 7. Just turning it around now. 8. I remember winding these like as kids with the the copper wire. 9. 10. That's 10. Have a look at the old core memory that you used to get women seamstresses to wind with their delicate hands. 11, 12, 13, 14, 15. So that's what I wanted, my 15. So I'm just going to try to space these all out now so they kind of begin and end in the same place. Be easier for me because I've got to wrap now the other one around and through and up and down all over this. Might be a bit tricky, but you can kind of get the idea. So we're spacing those all out, and then we're going to be using terminals A and B on here to connect those green ones up. Remember, the B is the bent one, this one here. So I'll bend it a bit more. It seems to have unbent itself. And because it's copper wire, we're enameled wire, we're going to have to take the enameling off. But look, you can see where you're going with it. So I'm just going to go do the red wire now off camera, and we'll come back here and solder this on. All done, and isn't it so pretty? It's so Christmassy. It's a festive little thing. So I'm just going to now eyeball it up just to see where I want to cut these, and I'm going to say boom. I might keep the old sort of bits of copper wire though. I think that's kind of snazzy stuff. You know, you sometimes see on old boards, don't you, the little twisty inductor things, and you definitely be hard pressed normally in your toolbox to have something that'll do the trick, but right here you've got it. You've got them right here for next time. So I'm going to have a go at sort of scraping off the enamel. So just going to see if I can do that with me side cutters if I'm very gentle. Very risky, by the way, if you're doing this at home, because if you cut that and it'll be too short and you'll be stuffed. Yeah, side cutters work pretty good. It's not like the really tiny, you know, the really thin wire, the thin gauge. It's much thicker gauge, so your enamel to wire ratio is a lot better on this. Harder to see though on the kind of ready copper coloured one. What I might just do real quick, see if I can tin them. Yeah, that tinned. And this one tinned too, so yeah, that was pretty cool. I kind of feel I can manage to do the others while the board is in situ, so I'm just going to solder in these two now. I say in, I'm just going to solder it on, like a surface mount component. Whoa, that's hot. These are super conductive, these wires. Just touching that end of that copper has just gone straight through to my finger where it was. Good. So that's looking nice. Got those two contacts A and F, and then we've got the two bent ones. I'm just going to lay those out. Could do with some tweezers on the tweezer torque. See more or less where you want that to be cut. And I dropped me spare piece of enamelled wire. The red one's gone. It's escaped. And that's the way we are. Let's get that last bit done. Just going to check if I apply heat to the end, is that good enough? Yeah, you can kind of fry off the enamel. It's another way if you don't want to scrape it. Just smell a bit, but apply a bit of heat to the very end. I'm just going to slip in there now. Let's solder those last wires down. Woo! That's hot. Sorry about that Michael and Jackson impression there. did get a little bit toasty on the fingertip. So that's sitting in there nicely. In fact, the wires really hold it flat. I was wondering if you had to glue it or something, but I suspect you don't because you probably have to twiddle that to tune it. So that's the daughter board in there. Right, last thing is the old resistor. So hopefully that'll arrive in a moment and we'll be fitting it as if it's by magic. Hi and welcome back. I have my resistor. It did arrive. It's right here eventually. So I'm just soldering a piece of wire onto the antenna. It's definitely not a long enough antenna because this is going to be one of those AM FM things. I think they normally have really long antennas and really long ground planes, and the instructions do tell you what to expect and what you should be fitting. But that being said, I've got a bit of wire and I found this crusty old radio, so I think we'll be probably alright running them next to each other. That's my aim. Let's fit that resistor in, finally. Where are we? Oh, there is an inductor, by the way. Look, L3. I missed that. Look at that. Remember I had that inductor that's lying around? I was going, what's that inductor for? Look, it's for there, L3. That's absolutely crazy how we missed that last time. Say we, it was me. You were probably screaming at the screen. Put that inductor in there. It goes in there. C7 though, you'll see is empty. That does say empty in the instructions, so that one I haven't missed. It's probably something to do with trimming up that antenna if needs be. Right, so we've got our resistors in there now. Do that last bit of soldering. Now the thing about this, we need two power supplies, so we need up to 35 volts for the high tension, and for the low tension it was pretty low. I think it was like a volt and a half, but, you know, I'm going to double check all that before I start pumping power into it. But that does leave an interesting sort of conundrum how you can do that. I've got a bench power supply, so I'm okay. But a lot of people won't have that, and the instructions show you taking 9-volt batteries and sort of connecting them end on end on end to bring the voltage up. Right, so that's our antenna. There's our on-off switch. Now we just got to connect our valves or vacuum tubes, and let's see which one goes where. We do have the two. I'm not sure just by looking at them if we can tell. You can see it's not really quite clear which is which, so we need to follow the instructions on this one. Tubes. Assemble the main board. Here we go. Final assembly right there in the bottom. It says V1 is a T4 and a V2 is an R5. So this is V1 and this is V2, and this one says a 1R5. So this would be on the V2 actually. So this should be a 1T1. So let's hope that's a 1T1. Not into... Yeah, it does. It's a 1T4, this one. So I'm guessing... Oh yeah, V1 is a 1T4. I just read that off wrong. That's fine. So I'm going to pop that in right where it belongs. Be very careful. If you think that, you know, the feet on integrated circuits can sometimes be a bit bent, this thing definitely looks like it needs a bit of care. But it's in. Valvey. Now I'm pretty sure they're not going to get hot or probably even glow or do anything like that in this circuit, but any doubt, you might as well give them a wipe down as well before you finish your final assembly. Just don't know what, you don't want any grubby mick juice on there. So this pin really is bent now. I'm really worried about this. Be very gentle. The last thing you want to do is crack the glass envelope, because then that's it. It's game over really. I don't think they won't operate unless they got a vacuum. It's in the name. Ugh. So that's them in there like that. Oops. Just going to give them a little wipe. Look at them in all of their glory. Right, I'm going to go and try to sort out power supply. Then we'll get back here. Got a quality setup here. Bench power supply 34 volts, 35 volts. A battery connected to the low tension, and that's at 1.48 volts. It's currently switched off. I'm going to apply now the power from the bench power supply. So now we've got 32 volts here, 1.5. The two valves, everything. So technically we could turn it on. It's a moment of truth. Popped it on. No discernible anything. I'm not even seeing any current actually going out the high tension. Now I'm just going to put my phone onto sort of YouTube or something and just start it playing. So the phone is actually playing something. So we do have technically sound going through. Not seeing anything. So we should put our little radio on here. Oops. Yeah, that's just how I remember these sort of things sounding. That's it. That's it. Oh, that's it working. I can't believe it. So I've got a tuning knob on the front here of the unit. Wow! I'm blown away. That's actually really amazing. That's working really well. I think we should try to find something, some music, because voice is easy, isn't it? Voice is easy, but I think music could be trickier. So free music. And you can hear that noise in the background. I kind of think, if I recall on AM though, you used to always get that, didn't you? Right. Let's see. I was just hoping we can... Oh yeah, that's it. That's our favourite track. Our Joachim whatever one. There we go. That warm sound. It's okay though, you can definitely discern it. Not sure how AM works, if it's picking up all the fluorescent lighting and all. Oh look! Hardly any buzz now. So there you go, that's it. Turn that down. Yeah, that's the kit. It clearly works. It does say if you're going to use it indoors, you should be able to get quite a good range. So you should get a range throughout your whole house. I guess with a bigger antenna and everything like that, you're going to get better range and probably better sound. But the thing that's cool about it, not only does it sort of allow you to play music to your old AM radios, but that sound does have that kind of oldie worldy warm glow, if you know what I mean. It's got that certainly a retro sound to it. That could be cute. Very cute little kit. I like that. It's blown me away. It makes me want to learn about vacuum tubes and how this actually works, which is kind of fortunate because the instructions it came with do actually have a whole big thing on how exactly it does work. Look, how it works. Literally a whole section on how it works. So that's the ITX Max Home Broadcast Tube AM transmitter kit. And yeah, crikey O'Reilly, that was quite a bit of fun really, but definitely worth investigating. If you like AM radios, please check it out. If you know anything I've done wrong with this kit in terms of setting it up, please let me know. I'd like to know, but I'm glad just on first time it appears to have worked. As ever, thank you for watching.